Oh, hey, you probably need some help with finishing up some broadcasting or signal flow type issues. This video is actually about how you troubleshoot these systems, just a brief overview on how I do it. And let me give you the basics and then you can figure things out. First off, your manuals are super important for you. If you're running a system and you've never checked out the manual, you need to do it. Go and find it. Google the thing that you are using and say, what's the manual for this? It's going to have information that I couldn't share in a video like this. I've read all these manuals and I read them again sometimes and I learn new things. So make sure that you're doing that with the equipment that you've got. Learn something about it. A couple other places where you can learn some stuff about the equipment specifically would be Facebook groups. There's a Facebook group for every piece of equipment these days. You're also going to find stuff where you can ask questions and get almost immediate responses. A lot of the websites for different manufacturers have forums on them, and you can go and write questions in there. You can go to Reddit, and there's a whole bunch of user forums for this type of equipment. Look for the specific thing you're using, or look for a general thing like theater lighting group and ask a question. How do I do this better? How do I do that better? And you're going to learn some things. I thought I had another one, but I can't remember what it is. So let's talk about the way that I troubleshoot and the way I think of general troubleshooting here at Lutheran West, or really anywhere with an AV system. I think of it in two different ways. Number one is signal flow, and number two is signal to noise ratio. So you're asking yourself what kind of problem you have first, and that'll guide you on how to fix it. A signal flow problem is simply, I'm plugging something in, and it's not making it to where I expect it to go to. What's wrong? We're trying to get through the path. The other type of problem, the signal to noise ratio, says I'm getting what I want, but it's not quite right. I need it to be better. So in the case of sound, it might mean, yeah, I'm hearing the sound of the person talking, but I'm also getting a lot of noise from behind from other instruments or radio frequencies, or there's just a lot of echo or something like that. That's the signal to noise ratio. Signal flow is where most of your problems are really going to exist. And I want you to understand that it comes in two different forms. There's the physical signal flow, which you need to know, and then there's the internal signal flow on something like a sound mixer or a video mixer. So before anything else starts, when you're plugging a piece of equipment in, a camera, a microphone, a television, or whatever, you should be able to say, hey, this wire goes to this port, which goes to this thing, which goes to that thing, and it go the whole way from beginning to end, from inputs to outputs. If you don't know that, that's your first job, is to learn and figure it out. I have videos on this channel that talk through the signal flow for pretty much everything in the school that I knew about, if I remember. So there's a lot of information up there for you that will help you understand the signal flow. If you're going to run a big event and you're in charge and you've never learned the signal flow, that is a scary place to be. Don't do it. Once you've identified that, now you're going to use some of the tools inside that signal flow to figure out, well, how far did the signal make it so far? Can I tell that my microphone made it up to the soundboard, but it's just not coming through the monitors? Because maybe that means the problem is at the mixer and it's not routed through, it's muted. Or maybe it's on the way out to a monitor send where that's not plugged into the right spot. You always want to figure out where you get to correctly first. Another form of this whole signal flow thing, though, is figuring out that, hey, I'm not getting from somewhere to somewhere. Try something that you know works. So if you've got two microphones and two cables, and one of them's making a signal and it works, and the other one's not, try switching the microphones so that you can see if, hey, now it works on the one that was bad, but this one's bad now. And that'll give you a clue as to what piece was wrong. The cables are some of the big culprits in this type of work. If the shield breaks on things, or there's a solder joint that comes disconnected, or somebody runs it over with a chair, they can lose their electrical connection and then they won't work. So it's always worth trying a different cable. But signal flow is really important, you got to learn it. The other type of, one more thing about the internal stuff. That's where you're going to learn that through a mixer. Sound mixers are pretty complicated. Video mixers are a little bit easier to understand. Lighting consoles have a whole nother language that you maybe aren't familiar with. So there's a little complication to the whole thing. But understand how signal flow and the path flows first inside of it too, because sometimes it's just a matter of you don't have a fader up, or it's muted, or you never set the gain to be correct. So the other type of troubleshooting that happens here a lot is signal to noise ratio. An example of that would be like, hey, I've got a choir, and every time I turn up the choir, I hear the drums as well because they're back over here smacking away. Well, that's the signal to noise ratio. And I define signal as the thing that you want, whatever it is. I define noise as whatever you don't want. So in some cases, like the case of the drums and the choir, well, through the choir mic, the choir is the signal and the drums is noise. Through a drum mic, the drums is the signal and the choir is noise. You are always going to have noise. It's always going to happen. Even electrically, there's noise. And the things that we use that are electronics, they impart some kind of a buzz or a hum. Now it's very, very small. If the signal's this big and the buzz is just this big, you can't even tell that it's there, so it doesn't matter. We're not trying to eliminate noise. We're trying to maximize the difference between the signal and the noise. That is a little bit harder to do than the signal flow type things. In the case of audio, often what this means is getting the mic as close as possible to the source, thinking about where your monitors are pointed so we're not pointing right back to a microphone that's going to cause a feedback loop, or keeping other instruments in places where you can control their volume somewhat. There are some places, like the rock gym, that are very noisy environments and sound bounces all over the place. It is very hard to get a clean signal because there's inherently a ton of noise in there. Acoustic treatment's really the best option, but it's pretty expensive and we don't really have any in there very much right now. So signal to noise ratio matters. If it's a video thing, like you're chroma keying, doing something with that, and you're getting like sprinkles in there, maybe you got to change the lighting so that your signal is a little stronger, or you adjust some settings on the key. That's another version of a signal to noise problem. Signal to noise ratio problem. So those things are the way I think about almost all troubleshooting. The only ones that get a little bit weird are wireless, and sometimes it is kind of a signal flow issue, and sometimes it's more of a signal to noise ratio issue. Wireless is kind of magic, the way that we think of it. You got to check to make sure things are paired up correctly, and then there's interference that's invisible that can come from the radio stations or television or something like that. And so sometimes it can be a little complicated. And wireless problems are just going to happen sometimes. Little drops. If you got big stuff, it's constant, then it's maybe time to look. The one thing I'd caution you on with all this stuff is that I wouldn't assume that your electronics are necessarily broken until you've gone through some of these other things pretty thoroughly. Does stuff break? 100%. It does. And sometimes it has to go out for repair. Sometimes it has to go for warranty. Sometimes you got to buy a new one. But oftentimes that's not the case. So if you're really thorough on your signal flow and you understand a little bit about signal to noise ratio, you should be able to use that to troubleshoot almost all the problems that happen here.